everyone. இப்போ நம்ம பார்க்க போற டாபிக் பார்த்தீங்கன்னா நியூக்ளியர் ஃபிசிக்ஸோட பேசிக்ஸ். ஸோ நியூக்ளியர் ஃபிசிக்ஸ் ஓகே. ஸோ நம்ம ஃபஸ்ட்டு வந்து நியூக்ளியர் ஃபிசிக்ஸில் வந்து ரூதர்ஃபோர்ட் அவர் தான் வந்து ஆட்டம் மாடலை ஃபஸ்ட்டு எக்ஸ்பெரிமெண்ட் மூலமாக ப்ரப்போஸ் பண்ணுறாரு. ஸோ atom model, maybe I will put atomic model, was proposed okay experimentally in 1911 by Professor Rutherford. Okay. Through what is that experiment? That experiment is alpha scattering experiment. Alpha scattering experiment. Okay. So the conclusion from that experiment is an atom consists of two things. One is called nucleus and it has electrons. So this is the conclusion from the experiment. Okay, the nucleus, this nucleus, okay, the size of the nucleus is estimated to be approximately equal to 10 power minus 14 meter, okay, in diameter. So this is the estimated size of the nucleus. So therefore nucleus okay, what it consists, if you further go into the nucleus consists of nucleons. Okay, the nucleus consists of nucleons. So what is that nucleon consists of what? Okay, so it has two things. One is called the nucleus consists of nucleons. This nucleon consists of both proton, which carry positive charge, okay, and it contain neutron, which is having negative charge. Now what is this proton and neutron? They are considered to be the two different charge states of the same particle. That is why we call it as a nucleon. So maybe I will write down that proton and neutron are considered to be two different charge states of the same particle. And which that particle which we call it as, maybe which is called a nucleon. Okay, a nucleon consists of a proton, neutron, and so on. Proton and neutron, sorry. Okay, next one is, now we can define a species of nucleus, which we are going to call it as a nuclide. Okay, so the notation for that, so let X be that nuclide, okay, whose atomic number which we can denote by atomic number is denoted by Z, and the mass number is denoted by A. Okay, so this notation describes that a species of nucleus which is known as and it is known as nuclide. Okay, so a nucleate contain what are they contain? So X, A and Z. Now what is this A? This A is called mass number, and this Z is called atomic number. Okay, now what is this mass number and atomic number? The atomic number, which is nothing but what? So this tells you the number of protons. Okay, and see, we know that the atom is electrically neutral, which means the number of proton, which is positive charge, must be equal to the number of neutrons. Those countings are done through a number called atomic number. Okay, so which is equal to number of electrons. So that gives the atomic number. Now what about this mass number? This implies total mass of nucleus, and that is the total number of protons and neutrons. So maybe I will write down that also. So that gives you total number of protons and neutrons. Okay, so mass number A, which is giving you the total number of, so we have neutron number and we have number of proton, okay, which is nothing but what? This is nothing but Z, which means atomic number is equal to number of neutrons plus atomic mass number is equal to atomic number of neutrons plus atomic number, which implies A minus Z, that is Z, is equal to N. That gives you number of neutrons. Okay, and therefore, so let us see an example. For example, chlorine, which is denoted by Cl 3517. Okay, and therefore what is A? Mass number is equal to 35, atomic number is equal to 17. Now what it implies? Z contains the number of protons, as well as we can also say that the number of electrons. Okay, and this gives you the total number of protons and the total number of neutrons, that is mass number. So A minus Z must give you the number of neutrons. So number of neutron is equal to 35 minus 17, that is equal to 18. So let us now see the classification of nuclei. So classification of nuclei. So the first classification is, that is, the nucleus with same atomic number that is Z, but different mass number A. Okay, so a nucleus may contain same atomic number but different mass number. Such a nucleus, they are called isotopes. So those things are called isotopes. Okay, so that means what? So this implies isotope means we have same number of protons, because same atomic number, okay, but different number of neutrons. So this is the idea. Okay, so we can write this as Z and A. Suppose I write like this. For isotope, if you put this table, okay, so this becomes same and this becomes different. So Z is same, A is different. Example, now let us see an example. Hydrogen isotopes. So isotopes of hydrogen. Now what are the isotopes of hydrogen? H11, H21 and H31. So these are the isotopes of hydrogen. Okay, now what is this H11? So this is the ordinary hydrogen. This is the hydrogen. So this hydrogen, okay, we call it as ordinary hydrogen, we call it as a hydrogen itself. So normal, whatever hydrogen we are using, we are deriving the Bohr atom model, எல்லாமே இதுதான். So it is an ordinary hydrogen. இது hydrogen தான், சரிங்களா? Okay, now we have another one which is called this one. It is called deuterium. Okay, this is an isotope of hydrogen. And we have third one, this called tritium. So these are the three isotopes of hydrogen. Now what is the difference? Suppose you take this hydrogen, ordinary hydrogen, that is hydrogen itself. Okay, now the proton number and the neutron number, if you calculate, see, Z is equal to 1, but neutron number, therefore A is 1, Z also 1. So A minus Z is equal to the number of neutrons, therefore it is 0. So therefore for ordinary hydrogen, that is for hydrogen, we have only proton, there is no neutron. So this implies it has only one proton but no neutron. Okay, the next one is hydrogen 2 1. So what is the atomic number? Atomic number is 1. Mass number is 2. Therefore mass number minus atomic number gives you the number of neutrons. So the number of neutron is 1. So which means it has 1 proton and 1 neutron. This is deuterium. Okay, and tritium if you take 1 3. Okay, so this contains atomic number 1 and mass number 3, therefore the number of neutron is 2. Okay, so this is the difference. So it has 1 proton and 2 neutrons. Okay, now notice that these quantity ordinary hydrogen so these things are there, right? So this part, that is 3H1 tritium, is a radioactive element. Okay, and deuterium, this part is deuterium, it is a stable hydrogen. Okay, and keep it in mind that you may see later in nuclear physics when we study nuclear reactor, something called D2O. Okay, now what is this? This is called heavy water. It is not hard ordinary hydrogen. Ordinary water is H2O. Instead we will use heavy water, which is D2O. Okay, so this is used as a coolant. So this we will be studying in nuclear reactor. Keep it in mind. Okay, later we will see about this, and let us see some examples. So examples for isotopes. One, chlorine. For chlorine we have isotopes like Cl 35 17 and Cl 37 17. So this is one type. Then next one is, okay, this is one example. So let us see another example. Silicon, that is Si 28 14, Si 29 14, Si 30 14 and Si 32 14. Sometimes this notation also used. Sometimes chlorine, for instance, 35 17, like that also they will use. Don't worry about this. So sometimes I will use this notation or this notation, doesn't matter. Okay, so the conclusion is isotopes of an element have identical chemical behavior okay, and differ physically only in mass. So this is a key point. Okay, so next என்னன்னு பார்த்தீங்கன்னா second one, nucleus with same mass number A but different atomic number Z, so they are called isobars. Okay, so the nucleus with same atomic mass number but different atomic number. So here in this case, if you consider this Z and A, okay, now this Z will different, so it will be different, okay, and this is same, mass number will be same. So example for this case, O oxygen 16 8 and nitrogen 16 7, so they are isobars. Okay, so this implies we can also write this species 1, nuclide 1, A1, Z1, and another one is X2, A2, Z2. This implies when we call it as an isobar, A1 is equal to A2 and Z1 is not equal to Z2, okay, such that this difference, okay, so they have they have same mass number but different atomic number. So this is A1 is equal to A2 and Z1 is not equal to Z2. Such a nuclide is, they are called isobars. Okay, they are called isobars. So third one, nucleus with an equal number of neutrons, that is the same n, okay, they are called isotones. So this means what? The number of neutrons are same, okay, they are called isotones. Okay, so example, C 14 6, nitrogen 14, maybe nitrogen 15 7 and oxygen 16 8. If you consider these three elements, now let us calculate the number of neutrons. So the number of neutron, if you formula calculation, in order to calculate that we use this formula, that is n is equal to A minus Z. Now what is n here? So n is equal to, A is nothing but 14, Z is 6, therefore 8, okay, and here also n is equal to 15 minus 7, that is 8, and here n is equal to 16 minus 8, that is 8. And notice that in all these three nuclei, the number of neutrons are same or constant, right? Here it is 8. Okay, so For instance, suppose I have 3 nuclei x1, a1, z1, x2, a2, z2, and x3, a3, z3. You can also extend to any number of nucleus, right? So just I have taken an example with 3. So I'm just writing the general case for 3. So which means if they are isotones, then a1 minus z1 is equal to a2 minus z2 is equal to a3 minus z3. Suppose I take one more x4, z4 and a4, then is equal to a4 minus z4 and etc. So this is the general formula. Okay. Next one, fourth one. This is about isomers. A nuclear isomer actually it's a metastable state of atomic nucleus, okay, in which one or more nucleons, protons or neutrons may occupy higher energy levels than in the ground state of the same nucleus. So what is happening here is, so we have same atomic number. In this case, the atoms with same, the species X, okay. So A with Z. So suppose I have two things, x1 a1 z1 and x2 a2 z2. Here a1 is equal to a2, z1 is equal to z2, that is z and a. So here it is same, here it is same. So it's an interesting case where both z and a are same. So but they differ from one another in the nuclear energy states and exhibit differences in the internal structure, okay. So this is what it will do, but these nuclei are distinguished by how this is by distinguished by their different lifetimes, okay. Such a nucleus we call it as isomeric nucleus or isomers. So the point here is, I'm just repeating, so they differ. So the nuclear isomer is in a metastable state of an atomic nucleus, okay, one with metastable state, okay, and another one with a different state, quantum state. So what is going to happen? So they do have same atomic number, same mass number, so they are same, but they're different, but they differ from one another in their nuclear energy states, okay, and exhibit differences in their internal structure, okay. Now how we can distinguish, because same A and same Z, how we can distinguish these two species? These nuclei are nuclei are distinguished, okay, by their different lifetimes. Okay, so this is a very interesting thing. Okay, so these nucleus therefore called isomeric nucleus or simply isomers. So they are called isomeric nuclei or simply isomer. Okay, so isomers are metastable excited levels with a fairly long lifetime. Okay, so what is an example for this case? For example, let us take bromine. This is 80 minute and this is 80 m and this is 35. It has lifetime of 4.4 hour, and we have one more 80 BR35 whose lifetime is 18 minutes. So this is one example for this case, and we have one more, for instance cobalt. Okay, cobalt 58. Okay, so the lower energy isomer, that is 58 cobalt. Okay, it has 71 days half-life. Okay, so this actually decays by electron capture and positron emission, and so this is actually low energy isomer, and we have high energy isomer. So this means this is also cobalt and 58 M stand for metastable. Okay, so here also we have seen this M, and this is 4.4 hour, right? 80 M stands for metastable case. Okay, so this is cobalt, and this has 9 hour as a half-life. Okay, and undergoes gamma decay okay, forming cobalt 58. So this is about isomers. Okay, the next one is, suppose fifth one, a nuclei having the same mass number A, but with the proton and neutron number interchanged. So what it means? So it has same mass number, but what happens? The proton number and the neutron number are just interchanged. Okay, so such cases are known as mirror nuclei. Mirror nuclei. So what it means? The number of protons in one nuclei is equal to the number of neutrons in another nuclei. Okay, let us see an example for clarification. Suppose we take beryllium 7 and 4 and lithium 7 and 3. So let us calculate A minus Z, that is number of neutrons for this case, which is equal to 7 minus 4, that is equal to 3. Now let us consider the other case, A minus Z, that is number of neutron, that is equal to 7 minus 3, that is equal to 4. And notice that in the beryllium case, atomic number is 4 and the number of neutron is 3. Whereas in the lithium case, the atomic number is 3 and the number of neutron is 4. So therefore, in both the cases, even though notice that this atomic mass number, the mass number is same, but the number of the proton number and the neutron number, they are interchanged, right? So notice this. Okay, so therefore they are called mirror nuclei. The next one is there is a pair of nucleides with the identical number of protons and neutrons in the atomic nucleus. Okay, for instance, suppose I have a nucleides, just a minute, nucleides. So we can calculate number of neutron minus the number of proton. So if you have different nucleides, if the number of neutrons and minus number of protons are constant, then they are called, so this n minus z is constant or same or constant, okay, for nucleides, then such nucleides are called isodiaphirs. For instance, so what is this? N minus z is equal to what is n? A minus z minus z. So this is actually n. So A minus 2z. For instance, suppose we take and the simplest example is 12 6, that is carbon 6, and 14 n 7 and 16 O8. We can calculate this n minus z. Now what is this n minus z? For example, the number of neutron here is 12 minus 6 is actually 8. So 8 minus, and this is 6. Okay, sorry, not 8, this is actually 6. Number of neutron is 6 minus 6, which is equal to 0. And for nitrogen, number of neutron is 7, okay, minus 7, therefore it is 0, and here it is number of neutron is 8 here, oxygen case, because A minus Z, that is 8, minus number of proton is 8, therefore it is also 0. So they are isodiaz pairs. Okay. Similarly, I can give one more example, that is radium Ra, okay, and that is 226 and 88, and radon 22286. So these are all also isodiophiles. Okay, so these are the examples.